Yes, thank you all for coming. Before I begin, I must say that today my wife was in a traffic accident with nothing serious at all. My car got ruined. So this presentation will not, if it goes bad, this will not be the worst thing that will happen in my day today. So I'm chilled. And with this said, let's start with ZIO and Pragmatic Zio. And first about me, so I'm Lachezar Yankov. I'm lead backend developer at Evolution for the NetEnt brand. I worked with Scala for about 4 years now, and a bit of Haskell before that. I really like Zio and Scala 3, so this will be only Scala 3 things. And I currently build game servers with Cat's Effect. I don't hate Cat's Effect, I like it as well. It's just like Zio is nicer. And we are hiring in Gothenburg. So we're hiring in Gothenburg. And so this presentation will be also given in Gothenburg. So this is why I will remove the braces when I get there. So if you live in Gothenburg for some reason, we can hire.
No remote work?
No remote work. We have people that work remotely, but I don't think for this it works.
Yeah.
And now where Scala shines, so you get essentially in the beginning of my career, I started with dynamically typed languages, and then I tried some statically typed languages, and the statically typed languages sucked because they were just translating some instructions into machine code. And then later on in my career, I kind of stumbled with Haskell and Scala, and suddenly the compiler was doing work for me. And this is where I kind of liked working with statically typed languages, because I invest some time and struggles during compile time, and then I don't get runtime errors. I don't get runtime errors, I don't get calls, I can't even omit writing unit tests, even though people tell me that I shouldn't, but I still think that if it compiles, then it works, and nobody can prove me wrong. And where Zio shines, or why I like Zio, well, to put it mildly, besides that you don't have runtime errors, you have a way to express errors that are not children of throwable, which Cat's Effect kind of enforces you to have. And you have type-safe dependency injection and domain-specific errors. But the start of my story is in 2020, when I was working for a small company that was developing systems in Haskell with Rio. And a Rio is reader T IO, essentially. So you have an environment, you have an effect type, and then you have this monad transformer between reader and IO. I don't know if maybe I should not bore you, but if you look at this thing, just calls F with the environment, and this is the function. So you get an effect back in IO, and you lift it to a monad IO. There is no domain-specific errors here. There is some mechanism for dependency injection. There is no way to control how you construct or destruct your dependencies that I'm aware of. Maybe there is. But it was a good beginning because it got me on the right track. And then I'm not going chronologically because after that I didn't work with Cat's Effect and Cat's MTL, but something similar you can do with Cat's Effect. I mean, in Cat's Effect you can do dependency injection in so many ways that that's probably one of the wrong ways. But essentially, you can have a reader T of an either T of your domain-specific errors and environment in your IO effect. And then you have to do a lot of lifting. So going through the stack and constructing your monads. But this gets you somewhere. So you get domain-specific errors like invalid config. You have the runtime errors that are not part of your domain that you cannot do anything about, so you erase. And then you have your dependency that you can work with. So kind of the same idea, maybe a bit better. There are other ways to do dependency injection in Cat's Effect. Probably this is the wrong one, but let's go with it. And then after I worked with Haskell and Rio, I started working with Zio. And it was kind of a distant memory of a thing that you did in the past, in the recent past, because it is kind of the same idea, but implemented differently. So you don't have these mono transformers. You have an environment, which is a type parameter called R. So R is for the environment, E is for error, domain-specific error, and A is for whatever you return. And this is built into the effect type. And the environment is not done with some mono transformers or RT. It's done with type safe map, which is probably the Scala way to do this kind of stuff, because the previous way is the Husky way to do it. And the E is not distant descendant of throwable. It could be anything. And then you get what you kind of don't like, what I don't like maybe, or you cannot escape it, but you have maybe 250 combinators on the effect. So you get the dependency by calling ZIO service. You get your domain-specific error with ZIO fail, and then you get your unrecoverable error with ZIO die, and then you can, work with your dependency. By the way, this was released in 2020 August. It's ZIO 1.0. So not that long ago, by John DeGo. Maybe there is some controversy around John DeGo. I'm not sure. But I think the overall idea is cool. I like it. And let's talk about R and E. So if you look at those four functions, the first one tells you almost nothing. It's a UID that goes into unit. And unit could be, printing line like hello world, or just returning unit. It could be so many things. And then on line 2, you kind of start seeing things. So there is an out service, and so the ampersand is intersection type, and the pipe is like a union, untagged union type. So you're essentially constraining your environment to be capable to do authentication and stuff on the item service or out service. And then you have some possible number of errors. So an out error, request error, and some kind of repository errors. And then line number 3, it takes a user, and when you do authentication, oftentimes you get the user. So maybe function number 3 is used in function number 2. And just by looking at these function signatures, you can infer things logically. And then the number 4 is kind of very verbose now, because we started talking about repositories and event publishers, and we have maybe a bit more errors. So number 4 is probably used by number 3. And you can kind of deduce this, because the type signatures tells you a story. And I think this is how I used to read newspapers in the 90s, when my father would buy a newspaper. Not that I was reading newspapers, but I would see the headlines, and then I'll decide what I want to read, which is usually nothing. But it is a way that a person will perceive information, right? You go through the headlines, and you will decide if you want to read the article or not. So I like this idea, headline-driven development, if you want. And I don't have a good transition for this slide, but ZIO recommends you to use, is it called clean architecture? Oh no, one called Bob Martin on domain-driven. It's an onion architecture, known also as ports and adapters, known also as hexagonal architecture. The idea is like you have these circles, in the core you have the domain services, and then you have infrastructure around the core, and then you have more circles. Usually maybe the third circle will be a web API. And the rule is like the core doesn't know that any other circles exist, but all other circles can reach to inner circles. So the domain services, they're called in an abstract way like event publisher. And the infrastructure services, they'll be called like, Kafka producer, or something related to how you actually built the application to do the actual work. So the domain service will be traits, and the infrastructure will be concrete things. Could be trait with implementations of the domain services. And then the web API or some kind of API will sit on top of that. And this architecture never makes sense with OOP. So I tried to make sense out of this. I tried to read books. I never probably wrote a good, well-architectured service based on object-oriented programming until I started doing work with functional languages. Because I think the reason is you mix behavior and data. Mix behavior and data, you get a lot of problems. You cannot really focus on the architecture, even get it to work nice. But how do you implement this architecture in ZIO? So there is a service pattern. It has 5 things. So the first and foremost, you have a service definition, which is a trait, so the thing on top. And then you have a service implementation, which is a case class, which is the thing on the bottom. And then the thing on the bottom extends the trait, the service definition. And the service dependencies are the things that you pass in to construct your implementation, essentially, of your service. And number 4 is the headlines, the accessory method. So, and your headlines are like the accessory methods is what is recommended for you to use in a like API setting. So if you want to other people to consume your service or to interact with your service, it could be other people that are inside your team building the same code base. And number 5 is probably the thing that is the most magical thing in ZIO, which is the ZLayer. So ZLayer is a kind of a smart constructor that you can essentially list all your constructors, and ZIO will magically construct them in the right way, starting from the root of the tree, or maybe it's graph, going onwards, outwards. You can actually do it by hand, but you can also do this. It was called ZIO Magic a long time ago. So you would just use this library and it will magically resolve your dependency. It will tell you if you give too much, if you give too little. So it will give you nice errors. But what about errors? So we talked about dependency injection. Now let's talk about errors, because maybe this is the killer feature of ZIO. I'm not sure. And it's a very simple concept. So in ZIO, you have 3 types of errors. You have failures, or your domain-specific errors. You have defects, your things that you don't recover from. And then fatals, things that you don't experience, because if you have a fatal, then probably there has been Armageddon, or your computer ran out of memory. So how would you experience this? I don't know. I don't know. What you throw that error, and what do you like? You can't do anything. And some time ago, I watched one talk from Sasha Solomon. She used to work at Twitter before Elon Musk, and then stopped working at Twitter after Elon Musk, and I don't blame her. And she said, like, there are 2, and the talk was about GraphQL. There are 2 categories of errors: errors that you can do something about, and errors that you cannot do anything about. So the ones that you cannot do anything is like internal server errors. The ones you can do something, they're your domain-specific errors. Because if you have an API that retrieves a user, maybe you have a blocked user, maybe you have a suspended user. Those are different responses, and the client needs to do something about them. The suspended user might be some kind of error message. A blocked user, maybe it will show the name and some other information. And in GraphQL, you kind of represent this with the union type, because GraphQL encodes errors in error array of string, which essentially makes it impossible to work with. But it's fine for unrecoverable errors. But for errors that you care about, you should probably use a union type with different results. And ZIO already has this, and Scala 3 already has this because it has untucked unions. But ZIO already has this, because you have this error channel, or the failure channel, and you have your result channel. Maybe it's not channel. So they're the same thing, or they're isomorphic in a way. So you can go from one to the other, and from the other a bit harder, but you can go to the first one. And we talked about Haskell, Scala, GraphQL, clean architecture. We didn't talk about Java. So Java was the original gangster because Java had checked exceptions. I love this. I wanted to work with Java about a year ago. and then why is this idea not so popular with Java? Or why C# doesn't have checked exceptions? I don't understand to this day. There's an article here that explains that, but I think maybe the reason is because Java was misusing checked exceptions for non-domain specific errors, like file not found exception. If I don't write a software that shows files or lets you browse files, that's not part of my domain. So I don't care about catching this. I would care, however, to catch things that are part of my domain. I mean, I wouldn't care to use Java or use something else, but maybe 20 years ago it was a good idea. But how do we deal with errors in ZIO? Or like usually you have it at the end of your universe, which is at the end of your program. So you would catch and then you convert them to something. Maybe you convert them to responses of some type like 401 or 404 or 403, or you will just die with them, and dying will, depending on what you use, but most likely will just make a 500. Or you can make 500 yourself if you want. Oh yeah, and the cool thing, I mean, probably the coolest thing is that failure segregates. So a fact that emits a particular set of domain-specific errors run after an effect that emits another set of domain-specific errors will result in a full list of all possible domain-specific errors for both effects. So here you can see from the number 2 calls number 1 or the other way around. And then some things disappear because either they were swollen, so they were either promoted to die or to defects, or maybe we just return a unit, like discarded those errors. And yeah, I was sure that I'm going to forget to say that I really, really despise that Cat's effect has throwable as a common interface on the errors of it, but yeah, so I'm really happy that ZIO doesn't have that. So you don't need, if you want, you can do it, you shouldn't do it. And in summary, after 19 minutes, what ZIO gives you. So you get type-safe dependency injection, you get dedicated error channel for your domain-specific errors, you get good design because of those two. You get structured concurrency that I didn't talk about because I'm not really sure what it is yet. I kind of like the idea to be able to spawn fibers and let them terminate or interrupt them, or let them terminate if they have like parent-child relationship. If the parent is terminated, the children are terminated. ZioStream, and then many backbone projects. I think some of them are very popular, others are not very popular and might be decommissioned soon. There was a new blog post from John DeGo about that, which I haven't had the time to read because it was published half an hour ago. So I don't know how this is, if this slide needs to change. We'll see later. And now I wanted to write some code, and I have, I think, 10 minutes.
Yeah, take your time.
Okay, and then what I have later, questions and thank you. All right. Now I know. So I'm very, very slow at writing. I mostly copy-pasted work. Don't tell my employer. But I have Copilot, I've disabled it because it doesn't obey. It's like becoming self-aware and it's writing wrong stuff, and I don't like it. So I wanted to get this example of the delete item and maybe try to implement it, not using our intellect at all, just trying without using too much thinking. Like in chess, when you improve your position, you don't need to calculate all the time. So I'm trying to improve my position without doing the hard calculating work. Yeah, that's probably what I wanted to say. So it's in the bottom, yeah, then I record. All right, now it's recording. I promise you.
Yeah.
I swear. I hope. So we have the delete item A and B. I think they cannot be called the same thing. Maybe they can be called the same thing because now they have different type signatures, whatever. And now there is an out service from the first one and there is a user in the second one. So probably we use the second one in the first one because you can get the user when you authenticate the user using the out service and you authenticate using a token. So I'm just going to not use my brain and just write delete item B. I'll provide the ID and I'll save. And then I'll look for errors. And then the error tells me like, you need to provide the user. And then I'll be like, fine, you're right. So I'll start writing provide. I'll provide some environment because this thing is called environment. And then I'll provide the user and I'll not use my brain. Instead of that, I'm just going to, okay, there is no user. It makes sense. So I need to extract the user somehow from the authentication service. So first I'll take the service and then I'll ask for out service to pull it out from the environment. Then I'll flat map on it. And there's easier way to do that, but I'm just going to do flat map because I don't know how to do anything with Zio. I'm a beginner with it. But that I can authenticate. And in functional programming, you can only do flat map and map. So if it is not map, then it's flat map. It's so easy. Now, I'll authenticate, and the authentication will take token. Can I just token? And then it will take token, and then it will give me back. I wish it was telling you what it will give me back, but it will give me back a user, an out user, which is a type of user. So I'll flat map again. And then this time, because I'm clumsy, I'll type in the type so that I'm sure that it's a user, not something else. And now I get the user, and this should have worked. No, that's fine. Found the user. Oh yeah, of course. I cannot just provide anything. I just need to provide the. So that function actually takes, gives your current environment as a callback, and then it asks you to change it somehow. So you can put the identity if you don't want to change it. If you append a new environment to it, it will like a monolith. It will combine them together. And now half of the work is done. And then the other half is using something like calling the item service and using the user.
Sorry, could you have like a line break or something so I can see them all over the
I wish it was possible, but honestly, in Scala, it's a bad idea oftentimes. So, but I don't know. Please, is that good enough? Maybe it's good enough.
Maybe before the flat map after authenticate. Before the dot.
You want here? No, you want here?
Yeah.
Ah, all right.
Yeah.
Perfect. Yeah, so but number two. So number two is we apply the receipt from number one, which is a service, and then you do item service. And I can't tell you how many times I put the wrong thing, so I'm just going to be a bit more careful now. And then we can do delete item, because the item service will take care of services of items. And then we can delete an item based on an ID. And this is enough, but we need to do something with the user, right? So let's say that we have some auditing service or something, but for this case, we're just going to print. We're going to use a flat map that discards the value in the callback. And then we will do ZIO service user. We'll take our user. We'll flat map it. Maybe we'll not flat map. We'll do it the correct way, which is ZIO service with ZIO. And then this here will be user. And I'll ask it to be user, because sometimes I just copy paste item service and I print out item service. It's really hard to be me. And now item with ID was deleted by user. And now you want line breaks, right?
Yes, please. How did you know?
You're making my life hard. No, see what happens. This is why we don't use line breaks.
Maybe try Emacs or Vim.
Emacs. I don't have enough keyboards for Emacs. Would that work? Okay. You see it. It's like amazing. And now we need to see that this works. And then we go here, and then there is demo API, and we have a placeholder for implementation, and we have an item ID, and we have a request. And now there is a small hint. So we need to convert the request into a header, out header, where the token is. So maybe we'll start with that. So request, and then there will be an extension method about out header. And now we get back an option. Well, luckily, ZIO has from option, I hope, if I can type, right? Yes. And from option, we'll essentially take whatever the option has or give you an error, and the error is option nothing. And we pretend that we don't have option nothing. We just have a nice request error. And all right, and that's step one. And then step two would be to call our thing that we worked so hard with the flat map, because we only have flat maps, right? There's nothing else, so there's nothing to think about. And then that's a token, and we call the demo thing and the demo service with the demons. And now we do delete item A. And now we have an ID, I'm quite sure we have. And then we have a token. Yes. And can this be a new line? No, sorry. And the last step is, so this thing will tell me like, dear dude, you gave me, I have a handler, and the handler expects something that could be a response. So I kind of cheat here because this error is impossible to read. But if we add this, now it should compile. I hope. Yes, it compiles. And I think the last thing left, so, and we didn't use any brain power. I didn't use any brain power. I just followed the, like a type hole development, which is not possible with Scala for some reasons, but it kind of works. And then you'll say that you don't see now probably. And I don't remember what's the API call, but I have a README for this. So the README will guide me. So I can list stuff. Maybe I can just do curl local. I need to start it first, right? Okay, I have the IP here. Curl localhost. The port is 6969. Items. No items, that's good. And now we create an item. I'm going to copy paste because we don't have enough time. And because I mostly like to copy paste. And we get an ID back. And if I list now, they will be here. And now we want to see our thing in action. Our thing in action doesn't take any data, but it's a delete. So we'll do x delete. And then we will put the item ID. And it will get back, it got back 200, all right? I forgot to put the V, but now it will get something else. It will give not found, because when you delete it, it's not longer there, right? So you get a 404, which, by the way, is part of the domain-specific errors that we had, because there was an error called repository error dot missing or something like that. And yeah, there is the output. So this is our authentication, fake authentication service that tells us that, not authentication, but the auditing service that tells us item with some ID was deleted by some user. Yeah, and I think this was the entire demo I have prepared. So are there any questions?
Yeah, one question.
Yeah.
About, you have this part of the code where you like caught except all the errors that could happen. Like I don't know. Have you worked with Rust?
No, I have not.
So like one thing I really appreciate about that is that essentially when you do a flat map and you get an error, there is an implicit conversion to whatever type and to whatever like surrounding error type you have. Because now it seems like you need to like match all these like very specific errors in one part of the code that are.
So it is possible probably to do some kind of a conversion implicitly. I didn't do it because I will pollute my domain. So my domain should not know about. So when the encoders, they need to be in the API. And if I have the encoders in the API, I can just have this switch, not a switch statement, but like a case that just matches on everything that's possible. But the good thing is that your case will be exhaustive because Scala will make it exhaustive. So this is part of a bigger project, which.
Or if you're trying to show something, it doesn't work.
Okay.
Now it works. Yep.
Does it? All right. So the actual project is not structured the way that I showed you it is, because it's an anti-pattern to do this kind of headline thing all the time. So you should do it for your edge interfaces of services, but actually I have handlers that takes dependencies like item service, does some kind of verification of whether you have some kind of errors in the input, and then spits out something. And I have utils that will do the conversion. And there are probably other ways to do it, but the thing is that I think this will be exhaustive. I think. Would there be any red squiggly lines? Maybe not. Maybe it's not exhaustive. Scary. But yeah, so I mean, there are no squiggly lines because this is a tap error. So, but here there should be red squiggly lines.
But you have a default case, right, at the bottom.
Do I have a default case? Yeah, thank you. But see, it kind of tells you like if you have enough extensions, it will tell you. But now it will be like, oh, it's not exhaustive. Do something, which is nice. But yeah, you probably are right that maybe if I have some kind of implicit conversion or codex from my domain into the API response, then it will be easier.
Because I assume like if you are on the like I don't know what you want to call the outermost layer, and you get the non-empty chunk error. It's like sounds great to me. Why would I want the chunk to be empty? That's some like inner component.
Yeah.
That doesn't want an empty chunk, right? Or it wants empty chunks.
Well, it's a non-empty chunk of generic validation error. So there you have some validation error here. So it kind of makes sense to have maybe validation errors in there. Yes. Any more questions or? Yes.
Yeah, thank you so much for the demo. Zio seems really interesting. I was wondering what systems if you were to bring this into a production system in one place, like, what systems do you think Zio is well suited for, and what do you think it might be poorly suited for?
I would say any kind of a business domain heavy system would be a great example because you get the ability to have many dependencies and to construct them. And so at my previous work, we used it to build everything, but we had a really massive project with maybe 50,000 or more lines and a lot of dependencies. And it was easy to go through that code and to be confident to refactor it and to have some kind of better mental map of it. I think Scala tree plus Zio. So if you have Zio without Scala tree, you will not have this union type of your errors. Many companies don't use Scala tree yet. So you need the correct setting. The correct setting for me is Zio2 plus Scala tree and a domain-heavy business application or microservices. That would be it.
That makes sense. Thanks.
Yeah, Christopher?
So you mentioned something along the lines that ZIO, like you're recommended to use something like the onion architecture or ports and adapters.
Yes.
There's often a tension between choosing very granular ports and services and choosing them to be very wide. I mean, just as an example, if you have if your application works with users, for example, would you expose a user repository for manipulating them, or would you expose a SQL adapter that will allow you to work directly with the database? What's the ZIO approach?
I would say you will definitely not have a SQL adapter of some sort in your domain. So you have a repository in your domain, and you have a service for your domain object that will represent operations on that type of domain object. And then you might have multiple repositories tied to it. You might have only one. I would let other services to be able to use other repositories. So there is no one-to-one correlation necessarily. Usually, oftentimes there is a one-to-one correlation, but you should not restrain yourself on having one-to-one. And this is where the headline-driven development actually shines, because you might have to have several repositories. You might want to have some kind of an interface of your service that uses complex network of dependencies to do its job. Maybe it's validating that the user has permission, writing an audit log, and deleting an item. So deleting an item operation exists, but maybe you have a special delete an item that depends on more things, and you don't need to write a lot of code. You just have 3 effects that you chain to each other, and you describe their dependencies. I don't know if that answers your question.
No, that's I'm happy.
All right, I'm happy when you're happy. Any more questions?
You hate for comprehensions.
No, why would I hate for comprehensions? I just think it's unnecessary work. Why I forget adding yield? I'm at a certain age where I just write for, and then the compiler tells me something I don't understand. Maybe things I loop. I don't know.
Then you go back to flat map.
And then I just flat map, and then the rule is if I have 2 flat maps, I might keep it. If I have 3 flat maps, I definitely make it a for comprehension. Any more questions? I think it's a wrap. Thank you all.
Okay, thank you.
Thank you.